everyone, and welcome to This Explainer. Okay, let's just dive straight into this. Have you ever looked down at the solid ground beneath your feet and wondered what exactly is hiding down there? I mean, we literally walk on grass, pavement, and dirt every single day. But beneath all of that lies this massive, totally invisible system that sustains life on our planet. Today, we're going to take a top-down journey straight into the Earth to explore a hidden, flowing underground ocean. It's an absolutely fascinating world, and by the end of this, I promise you're going to look at the ground you walk on in a completely different way.
Here's our quick roadmap for today's descent. First, the hidden underground ocean. Second, journey beneath the surface. Third, finding the water table. Fourth, nature sponges, the aquifers. And finally, trapped water and artesian wells.
Starting right off with Section 1, the hidden underground ocean beneath the surface. You know, we see sites exactly like this all the time in agriculture. A rusted pipe just practically exploding with a huge volume of crystal clear water flooding out into a lush green field to irrigate crops. It's a massive amount of liquid pouring out continuously. But when you stand in a field like this, all you really see is dry land and crops. Which begs a really simple but kind of profound question. Where does all this water actually come from? It's not coming from a nearby lake or some visible river. It's literally being pulled directly out of the dirt. But how? Well, to answer that, we need to completely change our perspective and look beneath the grass. That brings us to Section 2, Journey Beneath the Surface, moving into the subsurface. Let's peel back that top layer of soil and see what's actually happening underground. As we move down into the subsurface, the Earth is basically divided into two distinct zones. First, just below the surface, we've got the zone of aeration. Here, the spaces between the soil particles and rocks aren't totally full of water. Instead, they're filled with air and just a bit of soil moisture. But if you keep digging down, you eventually hit a fundamental boundary and enter the zone of saturation. Down in this deeper zone, all the pores and fractures in the soil and bedrock are completely 100% saturated with water. No air, just liquid and rock. If you zoom in microscopically on the sediment right up top in the unsaturated or vadose zone, you can clearly see large white pockets of air sitting right alongside the brown sediment, with just a little bit of water clinging to the edges. But as you trace your eyes down past the plant roots, through that transitional boundary we call the capillary fringe, you hit the saturated or phreatic zone. Down there, every single tiny gap between the sediment is entirely filled with water. Moving on to Section 3, finding the water table, the critical boundary. So, what do we actually call that critical boundary line where the air stops and total saturation begins? Well, that's the water table. And the thing is, the water table isn't some flat, static line. It generally follows the topography of the land, but it shifts around based on rain and drought. When the water table is high, it easily feeds rivers, springs, and shallow wells. But during a dry period, the water table drops. Suddenly, a spring might dry up entirely, and a shallow well becomes completely useless. So the absolute crucial takeaway here is that a well's success depends entirely on drilling deep enough to stay below this shifting boundary, firmly inside that saturated zone. But, geology loves to throw us a curveball. Actually, scratch that, it's more like a hidden shortcut. Sometimes you don't have to dig all the way down to the main water table at all. See, as water infiltrates down from the rain, it can occasionally get trapped on a thin, localized lens of impermeable rock, like shale or clay, sitting high above the main water table. We call this a perched water table. It's essentially a miniature, elevated reservoir. If you happen to dig a well right there, you might hit water surprisingly early. Which leads us perfectly into Section 4, nature's sponges, the aquifers. Let's push past the water table completely into that saturated zone. The rocks down here aren't just dead, solid blocks. We call them aquifers, and the word itself tells you exactly what it does. It's derived from the Latin aqua, for water, and fer, meaning to bear or hold. An aquifer is a saturated geological formation that doesn't just contain water, but is permeable enough to actually allow that water to move through it and be extracted. Honestly, think of an aquifer as a massive, multitasking underground machine. It's doing 4 huge things for us. First, it's a vital source of renewable water. Second, it acts as a massive storage reservoir, safely holding billions of gallons within microscopic rock voids. Third, it acts as a conduit. The water doesn't just sit there, it's actually actively moving and flowing through the rock under ordinary field conditions. And finally, as the water slowly squeezes through all those tiny pores and minerals,
the aquifer operates as an incredible natural filter plant, purifying the water along its journey.
To put some real-world visuals to this, here's what aquifer material actually looks like in the wild. While loose sand and gravel are really common, permeable sedimentary rocks make up a staggering 80% of the Earth's crust, and they serve as major aquifers. You've got sandstone with its highly permeable bands, or massive formations like limestone. Limestone is made up of minerals like calcite and aragonite, and it can hold vast, and I mean vast, quantities of fresh water right beneath our feet.
And finally, Section 5, Trapped Water and Artesian Wells.
Now we're hitting the absolute deepest, most pressurized, and, in my opinion, coolest part of our journey. Up until now, we've been looking at unconfined aquifers. Those are open at the top, water just trickles straight down from the soil, hits the water table, and joins the aquifer. But deeper down, we find confined aquifers. These are basically geological sandwiches. The water-bearing rock is completely bounded from both above and below by impervious formations, rock layers that water absolutely cannot pass through. The water in here is totally 100% trapped. And all that intense pressure, it creates a wild visual phenomenon. When you have a confined artesian aquifer trapped deeply between two confining layers of rock, and a pipe goes down into that trapped layer, the water can literally shoot straight up out of the ground like a fountain. There is absolutely no electrical pump here. It is defying gravity all on its own. The source material actually poses a fantastic question here, and I want to throw it right back to you. Can you explain exactly why that water is flowing naturally out of the well? If there's literally no pump pulling it to the surface, what unseen force is driving that water up into the sky? Well, the answer lies in something called the piezometric surface. See, because the confined aquifer is recharged by rainwater from a much higher elevation up in the hills, all that water flowing downward gets trapped between the impermeable rocks. This builds up immense hydrostatic pressure. The piezometric surface is an imaginary line that represents exactly how high that pressure wants to push the water. If that imaginary line is higher than the actual ground level where you drill your well, the trapped water forcefully rushes up the pipe to reach its pressure level. And boom, you've got a natural flowing artesian fountain right in your backyard. And that brings us to the end of our journey today. The absolute main takeaway I want you to leave with is this. The solid ground beneath our feet is actually a vast, incredibly dynamic, and heavily pressurized natural plumbing system. It's storing, filtering, and moving the very lifeblood of our planet in the dark, right below our shoes. So, the next time you walk across a field or see water pumping out of a pipe, ask yourself, just how deep does the invisible ocean directly beneath you really go? Thanks so much for exploring with me, and keep questioning the world around you.